Welcome to the Refrigeration Mentor Podcast and CO2 Mondays. Thank you so much for taking the time to come and hang out with us each week. Once again, it's been a blast. There's so much on the go. Today, I have a special guest, a good friend of mine, Wetzel from CoolSys and Advanced Refrigeration Podcast. So Brett has been training technicians for years and years, developing himself, developing his skills at all these different events. We've seen each other back in June, I believe. We're in person at the NASRC event, the summit, which is fantastic. Getting yourself out there, meeting more people, and continuing to train. Today, I wanted to have a conversation with Brett on training and development for CO2, the trends that we're seeing in here for training and education, and the way we're seeing the field for the technicians out there, because I think this is really important. We need to get the word out there that there is training, there is education, but you have to put the work in. It just doesn't happen, and you got to look for it sometimes, right? Even though there's a lot out there, you got to look for it. But so we're going to dive into a lot of this. Brett, welcome to the CO2 Monday and Refrigeration Mentor Podcast. How you doing, brother?
I'm doing all right. I'm currently sitting here in Georgia. This week's one of my travel weeks, so I came out here for Georgia for actually going to Corel tomorrow to get some training on their equipment, so I understand their energy management system, so I can help kind of develop some stuff for our technicians. And then also, I am actually going to be doing some CO2 training up in Chattanooga. It's been a long day with the travel, you know how it is, and that's what we're doing.
Yeah, no, and that's awesome, right? It's what it is putting the reps in, and that's what you're doing. You're continuing to train people, continuing to build curriculum, continuing to learn, right? Because that's what it is. If you want to continue to grow, you could continue to learn, and that's why you're at Corel. I do the same thing. Continue to try to grow my knowledge so I can share. I wanted to dive into kind of what you're seeing out there for the training development. We were back in June, I believe it was June. We were in, was it June or April? Can't remember. The end of April, May in Irwindale, and that was a great event. Like Danielle, Morgan, Gene, they put on an awesome event. All the manufacturers there, trainers, educators, definitely many industry. Can you talk a little bit about your experience at that event?
Yeah, so Danielle reached out to me. The one that started the NASRC was Brian Beitler, who has been with CoolSys for, I want to say like 45 years. He was the head of engineering and just a brilliant guy, and saw what was happening with the industry. And I think that was one of the driving forces. As you see, the NASRC is big with learning and development, and that's the whole reason for that event. So it's funny. So like Danielle called me when they first started originally, like thinking about what they wanted to do, and she's like, who do you think would be there? And I literally, I think I sat on the phone with Danielle for 2.5 hours, and I'm like, well, this is who you have to have out here. You have to have this person. Oh yeah, Rusty Walker and Zero Zone and Kaiser Warren and BAC and Gutner. And I'm just, and like she came back, like I think 2 months later, she's like, it was every single person, because I think there was 17 different individual classes. I mean, they had some duplicates and some stuff, but like 17 individual, because like Emerson did 2 or 3 different ones. True did, I think, 1 or 2 different ones. Rusty Walker did 1 or 2 different ones. And it wasn't just transcritical CO2. Some people were talking about Cascade. Some people were talking about liquid pump overfeed. You have Kaiser Warren's FTE, the full transcritical efficiency, right? So it wasn't one of those events like, hey, look at my product, this is what we're doing, right? It was nothing but training. It was really cool though too, because then you could actually have other trainers who normally don't get to kind of partake in some of the other trainings, and they could actually scope, like, what approach do you take, what things that you do as a trainer makes you stand out, and you get to see those things. It was a wonderful event. I mean, it was nice because I didn't do any training last year, so I was just a bystander and just went to as much stuff as possible. But it was a great event. They just released the dates for the three new ones that are happening. You have the one in St. Louis, Missouri, is November 14th to the 16th, and then that's 2023. And then you have Pittsburgh, Pennsylvania, which is March 20th to the 21st. And then you have April 30th to May 2nd, which is in Irwindale, California. And what happened was, this was so successful that now NASRC is having people beat down their doors like, well, I want to be a part of it. I want to be a part of it. I want to get the information out there, because it's not just U.S. manufacturers. I mean, now because of all the CO2 that's going in here, we're now having to outsource racks. So you have a lot of Canadian racks, you have European. I said, from my understanding, carriers trying to make a big approach into this, into the CO2 market. And I think they do have some single systems too, like the Revacol and the Kaiser Warren ones that are coming out. Like you said, trying to get the information out there so people understand what they're doing.
Yeah, no, and I totally agree. And they're such an awesome team. They're so nice trying to help and grow the industry. And it's a team effort, right? We all got to put in some work to help because it's our industry is not growing like the people inside. We're not getting enough people in. So we're not growing as fast as the technology is growing. So we need to figure out how to get more people in, and which they're pushing real hard on workforce development, which is fantastic. So let's dive into what you've been doing because you've been over the last couple of years since we met. You've been diving in, developing more trainings, training your teams internally. Let's talk about what you're seeing out in the field for training and development on your side, and what's working and what needs work on, and how can we get better to help more technicians out there.
Well, I think now with the landscape, I mean, it's just really about, just getting technicians in the field, because I remember when I was in the field, which was just 2 short years ago, but like even then, you had a lot more time to really kind of dig into stuff and kind of grit your teeth in. And now with a lot of people leaving the industry, I think kind of COVID put things in perspective for people where they didn't want to work so much. So they're looking for other things, because I mean, sometimes this job can be demanded. I've been trying to develop, we just purchased a subtech trainer, which I should be receiving this actually September, first CO2 transcritical class, which I think we're having in November. But also there's still other CO2 systems out there, right? We still have Cascade, we have liquid pump overfeed. Hail Phoenix makes one rack where it's liquid pump overfeed and Cascade together. It's all knowing the sequence of operation. That's one of the biggest things I push. I'm a real big numbers guy. So knowing the sequence of operation, my great grandfather taught me a really important lesson. He said you can fix anything as long as you know what it's supposed to be doing, what it's not doing, and what pieces that it's made up of. So, I mean, anyone that I talk to, if they look for advice, I tell them, just even if you learn one new thing a week, that's 52 new things that you now learn a year. And one time at 2 o'clock, 3 o'clock in the morning, you're going to need to know, and you're going to kind of beat yourself up. It's like, well, I should have just listened to that instead of scrolling through Facebook or Instagram. So we're doing that. I also make specialized training for like new accounts. Like, let's just say we bring on customer XYZ and they have this particular system. So usually what I do is I'll get all the refrigeration schedules, I'll get the P&ID diagrams and the program as well. And I make my programs based off of that, because I'm a real big numbers guy. And if it's easy for me to explain it that way to you, you can use that. Because one thing that I've noticed throughout the years, I've been doing this almost 21 years now, and it seems like people or technicians in general, not saying that you can't do it all the time, but they utilize past experiences to figure out things that they had before. And I'm not saying you shouldn't do that at all, but I mean, you should be treating everything like a brand new problem. Never expect that, oh, I've seen that one time here. You run through the numbers, because a lot of times if you call, any kind of technical support, what are they going to tell you? They're going to say, well, that's not the way it was anticipated to run. It's not running at the pressures. It's not running at the temperatures. So my theory is, as long as I can get it back to what the manufacturer originally designated it to do and how to act, theoretically, if it was engineered properly, I should be able to get it to run. And 95% of the time, that's probably the situation, right? Where I had to go out and help a job out in Arizona. And that's all we did. Before I even got out there, I was making phone calls. I'm like, I need refrigeration schedules. I need P&ID diagrams. I want the program. I want any kind of sequence of operation, because like I said, if I don't know that, I can't fix it. They have this system on this one particular manufacturer where they take a little bit off the accumulator. They assume that you get a little bit of oil back, because the oil separator might not catch everything, especially when you're running transcritical, right? Sometimes you get a little bit of oil carryover. And that being said, you get it back from the suction. Well, suction goes into this tall accumulator, it's 6 foot tall. So every so often it feeds into the suction of the medium temp. Well, okay, how do we do that? And what stipulations are giving that? So understanding that, what are the rules that have to happen before that thing actually transfers it over? Well, you have to have one compressor on. You have to have a superheat of 25 degrees or above. So knowing those things, one time it was set for 20 degrees originally. And I had a conversation with them. I was like, I understand what you're doing, but this valve is operated via a Belimo valve, right? So that Belimo valve, any Belimo valve, they don't have a set speed. They go at however fast they go. So my argument was that we'd have some occasional flood back where it would open up, and by the time the superheat would then calculate and go back, like, oh no, I'm flooding back. My compressor is filled up with, we're starting to eke a little bit of ice all the way up past the heads where it's obvious flood back. So we talked about it a little bit. I was like, can we just move to 25? So that if it does get down to 25, you have that buffer space, because as you know, with CO2, it's very, very critical to make sure you have an adequate superheat, because CO2 is very miscible with the oil. So it just wants to carry it right out of there. So any kind of lower superheat, typically on the subcritical compressors that manufacture, if you're looking at, you should always go from the manufacturer book, right? But Bitzer, I know from memory, I think it's 36 degrees superheat that they want on their subcritical compressors. And I believe it's 20 on the medium temp. You got to remember, you're having that medium temp or the low temp compressors feeding directly into the suction of the medium temp. So you are going to have that, so that's going to help mitigate that a little bit. But, the low temp, it's a little bit more crucial because it's a higher superheat. Making sure you understand, the days of just saying, hey, 20 degrees of superheat is good, as long as we're above 20. No, that's not always the case now. You have to read those manuals and read the fantastic manuals and figure out exactly what it's supposed to be doing.
Yeah. And I love that too, because even now, though, inside these manuals, I've talked to them, they say there's special exceptions, which I've seen for that example, that Bitzer one, because I said the same thing, but I've seen racks running at lower than that because Bitzer said it's good because of the oil's a certain temperature, the pressures. So you it's different with CO2. And I like what you said. So what are you kind of seeing the reception from the technicians now? Because you're doing a lot of training with them, you're doing field training and a lot of company training with the technician while you're up there with startups, for an example. What's that acceptance of that training, or how are they getting along with this? Because a lot of times the technician, it could be their first time on a CO2 site, because I've been talking and I've trained this year alone over 1,000 people on CO2. And I've been hearing, like, Trevor, I'm doing 2 startups right now at the same time, and it's my first ones. This is what's happening out there. What are you seeing out there and the reception of these technicians when you're in the field with them?
So one of the biggest things that everyone gets very hung up on, the whole dry ice thing. They're like, a dry ice is going to create dry ice. I was like, yes, it could if you have liquid in there and it's below the 67 psi. Yes, I teach just get the pressure when they're charging up the rack initially. Just get up to 100. Don't even worry about 67. Just get it way past there. Just remember that can happen. So when you're pumping down the filter dryers or anything that does contain liquid, that you don't create that. Yes, but it's getting them to understand that. It's getting them to understand that they're scared of the high pressures. They just are. They're like, it's 1,500 pounds. It could really hurt me. I hear, I need gauges for it. You initially, when you're doing the startup, right, you're checking all the pressure transducers to make sure they're calibrated. Once they're calibrated, you really have to worry about it now. And you're not going to hook up a set of gauges on the TC side, on the transcritical side. If anything, you're going to hook probes up. So that, and then the final thing that kind of throws people for the loop is the flash tank. That is the most confusing thing. If you really break it down, it's a booster style rack, which we've been doing even with HFCs for years. Back in the 70s, even before that. Having them understand that is kind of one of the biggest hurdles. Because when I was first initially trying to figure it out, I was doing the math and I was like, well, wait a minute. If it's at 70 degrees saturated at this pressure and I have 5 degrees of subcooling, and then that valve opens up, now, basically I don't have that anymore. I don't have that liquid anymore, but all the liquid doesn't disappear, right? There's a ratio. Typically, like when a rack is running subcritically, you get about 70% of liquid production out of the gas cooler and 30% vapor, and that's where the whole thing goes, where the flash tank drops that pressure into the medium temp compressors. And then, like I said, it just didn't make any sense to me. And then when you're running transcritical, it's like, I don't know, 50-50. 50% liquid, 50% vapor. And that's why we have, usually, if it can handle its load with 2 compressors during subcritical, usually you have to actually have 2 more compressors for when it does run transcritical. That's actually putting a very, very dense, it's not liquid, it's just a very liquid laden vapor. It would be a lower superheat. There's, some carryover from that valve because you're putting in a lot of velocity into there. And so I tell people, when I'm trying to describe a flash tank, besides all the math, I tell them to think of it as a recovery cylinder. How many of these guys have already hooked up a recovery cylinder when they remove charge from a regular rooftop unit? And for some odd reason, the blue is actually the liquid and it's reversed, and they actually end up pulling off the vapor. Well, what happens? You're dropping the pressure of the cylinder. Okay, you're dropping the saturation point, and then you get a little bit of boiling off. And that's essentially what a flash tank is. It's like if you were to accidentally hook up the vapor up to the top to fill up a system, it's going to drop that pressure down, subcool that liquid a little bit, basically boiling off to help subcool itself. Those are basically the 3 things that guys struggle with a lot. And The controls. I mean, that's one of the only other things that's really super different because of the certain sequence of operation, understanding all the controls. And with the supply and demand, it's really hard. You have multiple different manufacturers. Like, look, for the control of the HPV, the high pressure valve, and the DGV, you can have a myriad of different controllers. You can have RDM, you can have a Danfoss, you can have microthermal, you can have a Copeland. I mean, there's 4 or 5 different, Corel. There's 5 different manufacturers I just rattle off, and they're all different. They all have different set points. They all call it a little bit different. And trying to also remember that a lot of the settings and everything in there are a lot of times in Celsius and bar. And that's the other thing. Well, it only says that it's 38. I was like, well, 38 is actually 38 bars. Just getting them accustomed to also doing that and realizing, but once again, it's reading the manual. So a lot of times in my training, I'll break down like what all those set points are in different multiple controllers, especially when I do it for a certain area, right? If I know a place has iPro or if I know a place has Danfoss, I will make that training concentric around that. So it's a little bit easier. The theory really just, it stays the same, right? We're still doing the same thing. We're removing heat, turning that liquid into a vapor. It's just a couple things that are just a little bit different than a conventional HFO or HFC GX system.
Do you think it's just the knowledge base that technicians have? Do you believe that a lot of them that you're training are at the level of, say, for example, supermarket training, ready for CO2? Do you think like most of the technicians you're working with, are they prepared for CO2 at this point? Do they have enough supermarket experience to jump in there? Or do you think it's like a little bit of fear about the pressures, about the controls? What do you think it is like right now? Because you train a lot of people, do you think they're ready for CO2? Or is there a lot more that needs to be done for training and development?
Well, so what I did was when I did this class, I wanted to make sure like if anyone had this document, they could basically, figure out anything because I had multiple manufacturers. I had some Advanced stuff in there, some LNP stuff in there, some Kaiser Warren stuff, because we work on all of it. They just do it a little bit different. Like we're Advancer for increasing the superheat on the low temp. They have gas injection. LNP, they run the drain leg line from the gas cooler into a heat exchanger to raise that, but they use CDS valves to mitigate where it's going to go. Do I need more superheat? Okay, then I need to run it through the heat exchanger. Oh, if superheat's too high, all right, well then I need to back those valves off. So what I did was when I developed this class, I was like, well, I'm going to have level, I think for 5s and above, we have levels up to level 7. And I'm actually in the process, because once we went through that, because we did our first mock class back in March, I made the decision. I was like, well, I need an intro class. So the intro class is just getting their feet wet, right? Just breaking down the different flavors of CO2, so to speak. The cascades, the liquid pump overfeed, the transcritical, just making sure they understand just to see what it is, because I think that's part of it. There's a little bit of apprehension because they're like, I've never seen that before in my life. You're speaking a different language. I don't even know what the heck you're talking about. So if I break down and say, hey, listen, this is what a cascade is, and give a brief description, I'll give them some brief call outs of give them the refrigeration schedule right next to it. So we'll go through the P9D diagrams so they understand it real briefly. And then expected pressures and temperatures, because that's one thing that we don't do as technicians, which I just said this. I was talking with Brian Orr about this, and I was like, people really need to start checking stuff when it's running properly. Now, I'm not talking about putting your gauges on a single system or something like that, but I mean, if you have a rooftop unit or if you have this refrigeration system and you know it's working, a lot of times are you going to put your gauge on it? No, because it's working. But if you don't know then what those numbers are supposed to be, like how it's working when it's working correctly, you don't know how it's supposed to be running. So, that's where I come up a lot. I have a paper that I give out to all the technicians where it breaks down TDs of condensing units and expected subcooling, just so I can give you something to start. So example, like on a single self-contained system that's inside a supermarket. Supermarket's typically 75 degrees. Well, condenser on a single system typically has a 20-degree TD. Now, what does that mean? That means the saturated condensing temperature is going to run 20 degrees higher than what the room temperature is. All right, so now we're up to 95. All right, well, what's the liquid line supposed to be? Well, typically, because I've investigated, usually you get about 5 degrees of subcooling. So now you can use that as a rule of thumb from here on out. Now, you should always go back to the manufacturer guide, but if you can't find that specific information and you can't get a hold of that manufacturer because it's summer, everyone's running, everyone's calling everyone, trying to get information, you can use those rule of thumb to get you out. And that's a lot of times, yes, I'll give you the expected pressures and temperatures, but I will also give you a broader range of what it could be running, because it's not always going to be exact. It's not always running exactly what engineer spec is. So trying to make that a little bit more digestible for technicians is something that I pride myself on, because I understand that. And if I understand that, I can explain it to other people and make other people explain that as well.
So do you think that enough technicians are reading the manuals and diving in, putting enough work into the amount of stuff we need to know? Because in our trade, there's over 200 plus trades out there. I believe ours is one of the most technical. There's one of the most knowledge-based trade that's out there for refrigeration, because we work on everything. We go from plumbing to general labor work to electrical work to chemistry to physics to science, and we do all this HVAC and refrigeration. Do you feel that you see enough people putting the amount of work into what we need to know? Because honestly, when I first started out, for my first 5 or 6 years, I worked a lot. I worked 80, 100-hour weeks, but I don't feel like when I first started as I do now. I put way more work into learning and educating now. Every day I'm learning something about refrigeration. Do you see that? Are we reading the manuals enough as technicians out there? Are we attending enough events? Are we even getting the time to do that maybe as well? What are you seeing in that?
I think a lot of it's time. I also think that a lot of people don't even know where to start. I mean, like if you know nothing about transcritical or CO2 in general, I mean, there are a couple books out there, not very many. Rita makes a good CO2 book. It has an explainer on cascade and stuff. But if you don't know that those things exist, it's really hard to know where you should start, because you'd have to start basic, just to read about, to know simple operation, right, to start. Then once you build off simple operation, once you get there, then you're going to see what's actually there. Literally, that happened to me a couple of weeks ago when I went to Arizona. Like, I had my training set up, and then I saw some other components that I didn't have in my training. Well, I didn't know that they were using them. Well, now I do. So what did I do? Make sure that I get that. But I think not knowing where to start and the work-life balance for refrigeration is tough. I mean, so many people are retiring. I have a little bit of bad taste in my mouth with for-profit training centers, because sometimes they're not putting out the quality of technicians what we need. So the burden ends up being held on the contractors that hire them. They say, hey, you're HVAC certified. Well, what does that mean? Does that mean you can put your gauges on? I mean, if that's it, then sure. But I mean, you need to know a whole bunch more before you start getting into it. But besides, like I said, the work-life balance, not knowing where to get the information and not really even know where to start. I would read about the broad subject first and then start picking apart. Well, they have this weird oil system. Well, I got to investigate what this part does, what this part does. And it goes back to what I said before. If I know how it's supposed to work, what it's not doing, and what parts make it up, we can figure out anything.
Yeah. Do you feel that the industry needs to work together closer, kind of like what NASRC is doing, like from contractors to manufacturers to even end users, to get us where we need? Because I believe we're not in the right, especially in North America, we're not in the right position to the amount of CO2 that I hear that's coming, because it's not only refrigeration. We're talking refrigeration right now, but there's an onslaught of heat pumps and air conditioning equipment coming. And I see it. I understand the trends going that way. What do we need to do to get where we need to be?
I think it's more of a collaborative thing. We're going to have to work together, like I said, just like what the NASRC is doing, because they're bringing it to the limelight. And that's why it was so successful. It went so well in California. Like, well, we need more of this. And the fact that they then let everyone have the trainings that went on there is amazing. Like that's what we need to do collectively for the greater good of the industry, is get that information out there. If we don't get this information out there, we're going to have a lot of problems. I mean, we have right now CO2 in certain areas is kind of hard to get. And well, why are we using so much CO2? Yes, we're starting up a bunch of racks, but also knowing how the system works to make sure, especially on startup, to make sure you're starting up that piece of equipment properly and in the right sequence, because if you don't, you could be blowing copious amounts of CO2 up in the atmosphere. And okay, now I got to figure that out and then make it stop doing that so I can get everything else running. And once again, understanding the sequence of doing a proper startup is extremely helpful. I tell guys all the time that obviously the normal checks, the wires, making sure everything's wired right, make sure everything's every tight. But cool thing with a CO2 transcritical rack, it doesn't need the cases to run. At least the medium temp, right? I mean, we could run the rack by its lonesome. Yes, it might only be running off the one variable speed or digital compressor or what have you. But you at least there, after you did all your checks, making sure the HPV is working right, make sure the BGV is working right before you fully commit and be like, all right, let's open it up to a whole worm of problems that could be happening with the case, could be programming issues, could be whatever. But that's why you want to make sure the rack by itself is running tip top before we actually commit to opening up that liquid line and letting that flash tank liquid go out to the rest of the case.
Yeah, I agree with you there. I've been talking to a lot of field startups from manufacturers, from many different manufacturers. So these guys go out and help the contractors and technicians on the startup a lot of times. And I consistently hear the same thing from a lot of different ones. And they're saying that like when we get there, they're not even ready for us to be here. So on the basics, kind of like oil, kind of like on the setup, the wires all checked, all the things piped in. And sometimes they tell me it's not their fault. Sometimes the power company doesn't have the power to the building, but the refrigeration is there. What are you seeing on that side? Because you work with a lot of manufacturers that are going in there. What are you seeing there? Because they said like there's a lot of times I go out here and they're still 2 weeks behind because they didn't do the basics that needs to be done sometimes. What have you seen out there? And I think this depends on where you're at and what part of the North America, you know what I mean, too, for the skill level. What are you seeing on that side?
I think we can get the rack running, like I just stated, by itself, right? The medium temp would be running, no low temp compressor. But then being able to, let's just say the low temp cases are the ones that came in. Can't do anything with that. I need the medium temp cases. You typically need about 40% of the load of what's supposed to be on the medium temp in order to even remotely try to start the low temp. So I think the supply chain is holding up a lot of things. There are some mistakes on some engineering stuff, knowing that the case is supposed to be running at 28 degrees saturated, but most of the time, 90% of the time, there's no EPRs on CO2. It might have been engineered wrong based off of, it's going to be running that 18 or 20 degrees saturated, not the 24 or 26 that was originally designed for. Between that, the supply chain issues, I think that's one of the biggest things that might be holding up jobs. And it's, you got to remember, it's not just our refrigeration that's having a supply chain issue. It's other industries as well. You might have an electrician that can't hook up his panel because they don't have that panel right now. Well, if they don't have that panel, I can't get power to the rack. I can't even remotely start to do my checks, or even with the CO2, right? I mean, I can't start this up until I have more CO2. Like I need X amount of CO2 or just to get this rack running. Well, I'm waiting on that. And you got to remember, there's so many jobs going on with a lot of these manufacturers. It's hard to kind of, hey, I know you're supposed to come this date, but I need you to come this date. Well, I can't come that date because I got job A over in this running. So, I mean, that's an issue that I think contractors are running into as well.
Yeah. No, and I agree with that. I see that where there's a delay here and it affects I got to be somewhere else at this time, right? I see that multiple times, and I don't think there's enough people to be able to handle the amount of equipment that's getting put out there, even from the manufacturers. They're having a hard time to find those after sales technical people to go out, and they're relying on one or two or maybe three people when they're selling hundreds to sometimes thousands of pieces of equipment. So we really need to help grow that knowledge. So where do you see the next steps for CO2? Because right now, transcritical CO2 is something that's not going away in the supermarkets here. Subcritical, transcritical, secondary, which has been here forever. What are you kind of seeing the next 5 to 10 years with the industry? Because I know there's low GWP, it's happening. I see that there's systems out there. We're seeing 454B and other low GWP refrigerants. What are you starting to see, and what's kind of trends you think going forward for equipment in the supermarket industry?
Well, because of the GWP standards, I mean, I think they're gonna start, I think, repurposing a lot of maybe older equipment for other things and maybe adapt them. So let's just say you have a regular HFC or HFO rack, medium temp, low temp, whatever. They might throw a pump skid on there of CO2, throw some heat exchangers in there. So what are you doing? You're essentially reducing the amount of refrigerant charge because you have hundreds of feet of pipe. So if you just isolate that refrigerant, instead of having 1,400 pounds or 1,200 pounds, you might only need 400 pounds of an HFO. Repurposing old equipment. I think for the most part of the States, there's not that many single condensing unit type units out there. You have Revicold, you have Kaiser Warren. I think that is going to start hitting the industry. And I think with all the rest of the guidelines, there's a high probability we might start seeing ammonia may be being used in the supermarket industry. If they can pinpoint, I mean, because you don't need that much CO2, especially if you're running a cascade. Like I told someone before, I was like, my dream system would be ammonia primary, CO2 pump liquid secondary. Both of them are very efficient refrigerants. They're both have a very low GWP. They work well, but once again, as an industry, we're going to have to adapt to these changes. We have so many different types of refrigeration out there as far as CO2. We're going to have to just educate a lot more people. So in order for them to feel comfortable with it, because it's like anything else. Everyone's like, oh, VRF, way too complicated. Oh yeah, at that point, yeah. But I mean, if you break it down to its simple principles, it's still refrigeration. We're still removing heat. The process doesn't change.
Yeah, the thing about that too is like, oh, it's VRV, VRF. They've been doing it. Like people have been working on this for 30 years, 40 years. It's not new, might be new to you, but people have been working and installing successfully for that long. I remember watching a video from I think it was the early 90s, and there's a Daikin VRF system in the background on a roof somewhere. This 30 years, over 30 years ago now. So, and it was new to me when I moved to Australia and I was working out there, and all of a sudden I see all these pieces of equipment and they got these inverters in them. I'm like, what is this? I got central air back here. I'm working on packaged rooftops unit. So it's just what we know, right? And I think, like you said, it's putting those reps in for training and educating yourself. And I think it's being a bit more curious as well. I think there's a lot of people that I've trained. They told me, like, Trevor, I just got used to what I was working on, and I just had my blinders on for a long time, just working on that equipment. I didn't have other stuff, but now there's more equipment coming in my area or my store, and it's like, I'm intimidated, right? And like you said earlier, it's where do I start and who can I get help from? Like we're a small organization. We only have 10 technicians. We don't have like a big organization like you that has trainers and educators in the company, right? So what do you say to those smaller tech companies with technicians like that don't have training organization? What could they do to start developing their CO2 skills?
Like I said, the only book that I know of currently that covers basic CO2, like going over the different types of systems, that Rita book really breaks down individual systems. And then once you get your hands on that, then start looking at some of the sequence of operation. I mean, most equipment that comes out there, it has to tell you how it's ran because the programmer has to know how to program it. So being able to understand that is really important. And I feel like I'm repeating myself, but in order to be able to work on this, we need to know how it's going to work. But like I said, trying to get some basic information out there. I mean, that's one of the reasons why we started the podcast, right? Because there was not that much stuff out there. We basically break down a lot of the stuff to give you the building blocks to try to figure that stuff out. And as far as smaller companies, just knowing where to get the information, that's one of the biggest things. I mean, I'm sure if you call your manufacturer of the equipment that you're working on, a lot of those guys there, they've read, they've been through it, and a lot of times they know where to get a lot of the information. I know you post a lot of stuff of information that you find out there, because that's the thing, trying to make sure everybody has access to it. And what I actually did for CoolSys, I made a learning and development site, and what I did was I've been collecting documents for 21 years, just making sure I had everything. There's over 200 gigs worth of information that I've collected that's on there, that's all searchable. So what is it doing? It's not doing me any good, right? I mean, it did at one point, but I mean, I should be sharing that with everybody so they have access to it. You type in store XYZ and Danfoss, and you'll get information about Danfoss with that chain of supermarket or that chain of manufacturer. And that's what I'm trying to do. And that's what these smaller guys should be doing in order to start digging into this market, because it's coming and it's coming strong. I mean, look, Europe has, I think, 47,000 individual rack systems out there, and on top of how many single systems. I think in the States, what are we at? 1,500 maybe. I think by the end of next year, maybe 2,500.
I know I think Advanced puts out more in 1 year than all in North America. Same with Teco and a few other ones. They put out more, Carrier probably too, I don't know, but they put out more racks in 1 year than we have in North America. And that is going to be coming here. And it's starting because I talk to all the manufacturers just like you. They all have CO2 racks. They all, here in Canada, almost all of them make CO2 equipment. It's here. It's just, I think it's how is the industry going to react, right? We're doing it now, but I still don't think the amount of equipment that's going to get put in place from regulations that are coming up very fast, because the regulations that are starting now, I was hearing about them because I worked in the manufacturer, just like you, years and years ago. But now the timelines are starting to come up, right?
Well, I think it also comes down to, I think we need to be able to get more people in the industry, first off, right? Because we do have these very qualified technicians that can work on it, that are able to actually teach the things that they have learned in the field to the people that haven't been able to do that. But you can't do that if you're running and gunning doing 80, 90 hours a week. So are you going to be reading your daily manual? No, you're not. You're trying to make it through the summer. So being able to get more educated younger kids that can start handling the more basic self-contained, the walk-in, the rooftops, and then be able to work with some of your higher level guys to get them A+ technicians on the CO2 and the more newer equipment and technologies out there, and being able to give them a break. If we give them a little bit more time to do some personal development, they're more likely going to be reading that than if they're running 100 hours a week. If we get more lower level guys in order to help with some of that, to lift that load, so to speak. And I know it's a crunch everywhere. There's not one technician, one person that I talk to that's like, oh yeah, we have an abundant amount of people. We're just getting tons of technicians everywhere. No, not at all.
So what do you think is causing the 100 hours a week? Is it because there's a lot of callbacks? Is it because there's not enough, like you said, lower level people coming in? Because depending on where you're at, it's going to be different too. Depending on where you're at in the country is going to be different. Because I talk to all these contractors. You think, what is your opinion on what is needed? Because earlier you said too that you don't feel like a lot of the for-profit schools are pumping out the right quality techs. And I've heard this from contractors. I got a lot of contractors who hire me and say, I just got a guy who did 2 years or 4 years, and they're not where they need to be. They're not where I need them. This is why I'm hiring you, to get these guys up to speed faster. What's your idea on how to help this?
I think instructors need to be paid more. There was a college somewhere that had a whole bunch of rack equipment, and he didn't know how to fix the rack equipment. So how do you then teach the kids that you're supposed to be teaching the stuff that you don't know about? That comes down to, if an instructor is not getting paid a lot, not that this is the right thing, right? That, well, if I'm only getting paid this, why should I learn all this other stuff? I'm just teaching. Because you're bringing in the new people in the industry, the new blood. I mean, there are people retiring at a higher rate than what people are coming in.
Oh, by far. And that's a good point. I think in general, our trainers, educators need to be getting paid more, depending on what it is. But ours is a specialty trade, right? Like, we're not refrigeration specialty. Like everyone does. I see they put a lot of money in the HVAC side, because most of the schools in Canada, they got really strong HVAC programs. Their supermarket refrigeration programs are not very. There are some, don't get me wrong, like the 787 here, awesome. They got lots of guys that are supermarket, one in Algonquin, like there's some schools that have it, but for the amount of schools that are out there, they're pushing out gas fitters and HVAC techs and residential HVAC techs. Do you see that the same way in the US? Is that similar?
It seems that way. Like, I mean, if I had my way, if I had a magic wand and tomorrow I could start a school, I would make sure they had the basics of rooftop units and single systems and walk-in and self-contained. And I wouldn't teach them any of the rack stuff, because that we can build up. We need to make sure they have the basic fundamentals down first. They need to walk before they can run, right? So I can't just be like, oh, you went through school, go work on that transcritical over there. No, I can't do that to the kid, right? You need to make sure that he is comfortable with that and being safe as well. That's the other thing. Something as simple as just safety, just knowing
how to put a ladder up properly.
Yeah, I mean, because you might have a kid that fell off, an 18-year-old and fell off a ladder. I mean, that's a horrible thing, but you need to teach all these things. It isn't just the basic refrigeration cycle. We want to make sure to be able, because a lot of times the contractors then have to spend money to get these guys up to par. I mean, we're putting on a job fair out in California where we're having a bunch of people come out. These are people that have been through AA programs, associates programs, which is great, but a lot of the people aren't spending that 16 or 19. I heard a number, $19,000 for 2 years of training, and that's cheap compared to college. But not everyone is doing that. A lot of people are like, well, I could be HVAC certified for $2,500 in 2 weeks. There needs to be standards, and that's why I really wish that United States would adapt what you guys have up in Canada, where it's You have an industry standard that this is all the stuff that you have to be taught before you can actually be considered certified. Not that everyone that goes through the system, you have some better students than not, but you need to have some sort of standard across the board. You can't just call it continuing education and just be done with it. That's one of the things that I see out there.
Yeah. So what could get more people in? Because I get this conversation I have with a lot of different people. Some people say that we get paid enough as a refrigeration technician. Some people say we're not even close to paid enough. What is your outlook on the pay for technicians? Because it's different all over. Even in Canada, it's different depending on if you're in a city, if you're outside, you're with a union, non-union. As a whole, do you feel that refrigeration technicians are getting paid enough money in our industry for what we do?
No. I mean, if you can go right out of school, like going to a program and let's just say someone wants to hire you for $16 an hour, you're like, well, hell, I could work at Taco Bell for $18 an hour. Why should I have to learn all this stuff? I could do some easier job and not have to learn all these technical skills. So like you said, we are electricians, we are fitters, we are laborers, we are physicists, we're chemists. I mean, we're it's the gambit. I mean, we're doing a lot of different things all together. And that's what makes, refrigeration mechanics in general or technicians such high value or high demand, because we know all these things together. There are just single trades where, oh, this guy's just an electrician. I'm not downplaying electricians at all. I'm just saying that, we have to know the gambit of everything that goes in that trade, especially when you start getting into supermarket, right? And, you have the startup guy that basically needs to know everything. Oh, that's not done right. This, he's constantly going over everything.
Yeah, and I was driving down with my family through past an employment agency place the other day, and I was talking to my wife, and on the sign it says no experience at all, forklift drivers trained on a weekend, $26 an hour to start. I'm like, wow, $26 an hour to start. And
all right, I'm leaving now. I'm going to go apply for forklift driver.
Refrigeration technician. I don't know. I can't remember what the starting. I think we're 20, like here where I'm at, $20 maybe the starting rate, maybe 22. I'll have to check their agreement again, but that's probably where we're at. And yes, it's different, but 2 weeks, usually you got to do a pre-apprenticeship before you get a job with a contractor. You do a pre-apprenticeship or you do a year as like a truck driver or a laborer, you know what I mean, working around the shop before you can get on as apprentice. But I'm like, man, that's interesting, because like a lot of the technicians, especially the good technicians I know, they need to be paid more. Even they're getting paid higher than the union rates, and they're getting paid higher than usually everyone at their companies. But I still think for what they do and how they fix stuff in such a short amount of time, and there's no callbacks and the customer's happy and crushing it, they need to get paid more.
100%. I agree with you.
I agree with that. Awesome. There's quite a few things that we talked about here, talked about some of the trends, talked about some of the training, some of the stuff that you do. How can people get a hold of you, get a hold of the things that you want to do, learn more about what Brett and the Advanced Refrigeration Podcast has, as well as CoolSys has going on?
So at CoolSys, I'll speak briefly about this. So we have 4 training centers throughout the country. We have one in Jacksonville, Florida. We have one in Menominee Falls, Wisconsin. We have one in Fullerton, California, and one in Houston. We have 88 offices throughout the country, and we're in just about every single state. We usually train in between October, November, December, and January, February, March, typically when we do our training, because of the slow time. Because if I try to pull someone out in the middle of summer, I'm going to get some nasty emails back. There's no way that that's going to fly. We're constantly developing new things. So we do have a level system. We're building a level system for a CoolSys like commercial, which is like the smaller mom and pop, like gas stations, the Starbucks, the non-commercial, big commercial racks, and then cold storage. So we're building that out now. We're going to be doing our first classes for them this year. And then we're just going to keep building on. I mean, I purchased VRF. I mean, a lot of people are like, well, I'm not going to work on VRF. Yeah, you are. Yeah, you are. Because, I mean, the refrigerant charge has to go down. So, that's one way to mitigate that, right? Is having VRF. Making sure the technologies are up to date to what we're working on. I probably just purchased 3 Daikin mini splits, and I basically mounted them on a table, mounted them on some Unistrut, and what I'm having them do is wire this thing from start to finish. And that way they're wiring up the communication cable, they're wiring up the high voltage, piping it in, pulling the vacuum, making sure the vacuum is stable. and then charging it. And then at the end, I'll have you recover it and then pull it all back apart. So for the next person. So, I mean, there's certain things that we're doing. I'm also making individual classes. We've always had the level classes for the commercial industrial. And so now what I'm doing is trying to develop different classes. Like I said, the intro to CO2, which I'm still working on. The CO2 class that I have developed, we'll have our first official class. Like we did a mock class, like I said, of like 20 students all at one shot, which was kind of a trip. The only difference is this time around, we went to a field trip to a facility just to see one running. It's an operating store, so we can't, hey, pump this down. No, because we have product. So with the transcritical trainer that I purchased, that's going to be in our Houston facility, my thought is we're going to do essentially a startup on it. It's going to teach you all the programming of what you have to know. It's going to teach you the right process, showing you that we got to making sure we pull a good vacuum. And then after that, charging up to 100 pounds. Like we're going to go through an essential startup while you're learning everything about that rack, including the program. Like I've broken down a lot of the Copeland. They have a lot of flexible combiners, digital controls, making sure you understand that. Because once again, I'm back to the fact that you have to understand how it's supposed to run and how the program's supposed to work, because there might be a programming issue, right? Unless you actually know how to read that Boolean logic in order to break that down, you might not be able to figure it out.
Yeah. Awesome. That's fantastic. Well, Brett, I want to thank you so much for taking the time, sharing some of your knowledge. Really appreciate it. Always love having conversations with you. I look forward to chatting with you more on CO2 because this is what we love doing. I want to thank you once again.
All right. Thanks, Trevor. Hey, and don't forget to go to Advanced Refrigeration Podcast and check out the podcast, guys.
Yeah, definitely check out the podcast. Thank you, everyone, for taking the time to hang out with us. Once again, share this on Instagram, share it on LinkedIn, Facebook, and really, we're trying to help the industry out, grow their knowledge, and I appreciate all of you. Thanks again. See you, everyone.
Hey, thank you for watching this video. I do hope it is bringing you a lot of value. If you are looking to grow and build your refrigeration teams and want them to learn CO2 refrigeration, head to the refrigerationmentor.com website, click to contact us, and let us know how we can build a culture around training inside your organization. Let's get a conversation going.